A designer wishes to construct a rectangular garden adjacent to a large building. She has 120 feet of fencing to be used for 3 sides, and the 4th side will be the exterior wall of the building. So what dimensions would yield a garden with the largest possible area? So again, 3-sided fence adjacent to a building, 120 feet of fencing total. We want to design that to give us the greatest area for our rectangular garden. So you have a building. Let's go ahead and construct one. Visual representation of a building. We have 120 feet of fencing to make a rectangular garden outside this building. So I will go ahead and draw the picture. So those 3 sides have to add up to 120 feet. So let's label them. We'll call this X, call this X, and we'll call this Y. Again, we have a total of 120 feet. So what do we know? We know X plus Y has to equal 120. Or if you like, 2X plus Y has to equal 120. Now, what was our goal? Our goal was to determine the dimensions that would yield a garden with the largest possible area. So we come back and look at this. What is the area of this garden? Well, the area of a rectangle is length times width. This is X, that's Y. X times Y is the area. I would like to have a function of only one variable. So what is Y? Well, I can solve for Y. Y is 120 minus 2X. So now my area, being X times Y, would be X times 120 minus 2X. So area as a function of X is that, multiplying it out a little bit, we get 120X minus 2X squared. So our goal is to determine the maximum area and the dimensions we would need. What will little x and little y be to give us that rectangle of maximum area? So this is the area function. This is what we want to maximize. It is quadratic. The x squared term is negative. So we know it's an upside down parabola. So we will have a maximum. So let's go through the process of determining what that value is. So we have a of x is 120x minus 2x squared. I'm going to rewrite that as a of x is negative 2x squared plus 120x plus 0. This is in the general form of a quadratic equation. So ax squared plus bx plus c is our function. I'm just going to call f of x. Give it a generic name here. We know the vertex occurs where? The vertex occurs when x equals negative b over 2a. So in this case, b is 120, so negative b, negative 120 over 2a, over 2 times negative 2, negative 120 over negative 4, which I believe is going to be at 30. So the vertex occurs is at x equals 30. Well, that should be the point that gives us maximum area. So if I plug that in, what is the area when x equals 30? Plugging 30 into that equation, we get 120 times 30 minus 2 times 30 squared is what we're looking at there. So we'll go ahead and we will do that on the graphing calculator. We go ahead and pull that up. So we need 120 times 30 minus 2 times 30 squared. And this represents area. What do I get? We get 1800. So A of 30 is 1800. So remember, that's our vertex. So in this situation, when x is 30, and I believe that's feet are our units here, the maximum area would be 1800 square feet. Now, we've solved for x and we've solved for the area. We haven't solved for y. So let's go back and look at our original picture here, right? This is what we had. We had this picture representing our building with the garden outside the exterior of the building. Little y is 120 minus 2x. We've established here that the maximum area occurs when x is 30. So what would y be? Well, our equation here tells me that y is 120 minus 2x. So let x equal 30. So y is 120 minus 2x. So y is 120 minus 2 times 30. Y is 120 minus 60, so y is 60. So looking at our picture here, x is 60 feet. Here again, x is 60 feet. Check that, x is 30 feet. X is 30 feet. We saw that on the other page, right? X is 30 feet. And then y, we just did, y was 60 feet. And then our maximum area is how much? 30 times 60, x times y is 1800 square feet. So to clarify what we have here, maximum area of the rectangle is 1800 square feet. (1800 square feet). What did we have? What did we start with? We started with 120 feet to build our garden. So the two short sides were each 30, and the long side was 60. So I'll write that down. Two sides of 30 feet and one side of 60 feet. Yield the rectangle with largest possible area. Now let's try this again on the graphing calculator. So we know this is the function we're trying to maximize here. A of x is 120x minus 2x squared. So remember, the x value represents this x, but the y on the graphing calculator will be the area, not the little y here. So let's jump to the graphing calculator again. We will put that function into y1. We'll clear what was there before. And we have 120x minus 2x squared. And I need a decent window. We thought the maximum was at 30. So my window has to at least get to 30. So 0 to 1,000 is too much. But maybe 0 to 80 would be okay. Scale it by 10 sounds good. What did we say the maximum area was? It was 1800. So my y max has got to at least go to 1800. So let's put in a few negatives. Maybe the minus sign is here, don't forget. Minus 200, maybe to 2000. And then put that in at 100 would be fine. And that should be pretty good. Let's take a look at our graph. What x value gives us our maximum y value? Remember, the y value represents area. Second calc, maximum is number 4. Left bound, move the cursor a little bit to the left of where it reaches the pinnacle, where it reaches the peak. Enter. Right bound, Put the cursor a little bit to the right of where it reaches the peak. Enter, guess, put it somewhere in the neighborhood. And sure enough, the x value was 30. When x, that was the short side of the rectangle, was 30. Y, which represents area, gives us a maximum area of 1800, and that reinforces what we solved using algebra strategies.